Lesson 49 is about the multiplication of polynomials. So we were just adding polynomials together, right? That's what we just had on this last quiz. That was probably lesson 48, I'm guessing. We'll see. Yeah, so the addition of polynomials was lesson 48. Now let's talk about multiplying polynomials together. So when you multiply polynomials together, you have to multiply every term from the first polynomial by every term in the second polynomial. All right, that's our basic rule. And so if you have something like this, 4x plus 5, which is a polynomial, and 3x minus 2 multiplied together. And I hope that it's starting to click for you guys if some of you were confused about this. When you have something two things that are right next to one another, that always means multiplication, right? If I have 4xy, since the 4 and the x and the y are all right next to one another, you can think of that as 4 times x times y, right? And so any of our rules that apply to multiplication will apply to this here. So when we see 4x plus 5 and there's no sign in between here, it means that they're all, this term here, this polynomial here is multiplied by this polynomial here. All right, so just don't forget that in the process of all these things. Don't look at this and think, oh, I'm adding polynomials. No, you're not, because there's no plus sign in between these guys, right? Because we've got the parentheses right up next to one another, it means we're multiplying those two together, okay? And so what did I say the rule was for multiplying polynomials? I said every term in this polynomial has got to be multiplied by every term in this polynomial, okay? So let's just do that one at a time. Now, we kind of have a unique name for remembering how to multiply. What are these? You guys remember we talked about the specific names of polynomials? So you have monomials and binomials and trinomials, and we didn't go higher than that. But what would this be as far as those specialized names? You guys remember? The hint is in this polynomial there are two terms, and so yes, that would be a binomial, right? So we've got two binomials multiplied together, and so our special way to remember how to multiply binomials is to use the FOIL method, which means you're going to multiply the first terms, then you're going to multiply the outer terms, then you're going to multiply the inner terms, and then you're going to multiply the last terms. All right? The reality is you don't really need to remember this as long as you just remember, I've got to multiply this 4x times everything over here, and then I've got to multiply the 5 times everything over here. All right? So if the polynomials get bigger than just binomials, you still remember how to do that. So the FOIL method is really doing that. It's taking the 4x and it's saying multiply the 4x times this, then multiply the 4x times this, and then we have to multiply the 5 times this, and then we multiply the 5 times this. Right? That's first outer and the last. Okay? So let's do that. 4x times 3x gives us what?
12x squared.
12x squared. Good. Then we're going to multiply the 4x times the 2. Somebody besides, put your name on the board, Liam. Someone besides Liam. What is 4x times negative 2? Negative 8x, right? Don't forget the signs. What is, then we're going to do this one here, 5 times 3x. It's an easy time to get your name on the board. Someone not on the board? 5 times 3x? 15x. Is it positive or negative? It's positive, right? So plus 15x. And then the last easy time to get your name on the board for this class, 5 times negative 2? Negative, who said that? Okay, negative 10. Liliana's like, I'll take it. Is it 2 ends or 1? It's just 1. That's what I thought, but I was second guessing myself. So negative 10. All right, does everybody see how we got those numbers? Make sense? All right, are there any terms that we can combine? Now that we've written it like that, we're back to adding. When we're adding polynomials, we always have to look at the terms that add together. So are there any terms that we can add together? I hope you're thinking yes. Which terms, Hannah?
8x and 15x?
Yes. So I want you guys to get in the habit of saying not 8x, but negative 8x, right? Negative 8x and 15x, we can add those together, right? So negative 8x plus 15x is going to be a positive 7x, right? So we're going to rewrite this as 12x squared plus 7x, because the combination of the two is positive, minus 10. And that would be our final answer. Okay? Any questions about that? All right, so let's say I gave you something a little more complicated. 4x minus 2 times x squared plus x plus 4. It's a little more complicated because now this is not a binomial, it's a what? Three wheels on my little trinomial, tricycle, right? There's three terms, so trinomial. But the process is still the same. I'm going to take this 4x and multiply it times the first term. Then I'm going to multiply it times the second term. Then I'm going to multiply it times the third term. And I'm going to do the same thing with the negative 2, right? That's all we do. No matter how big it gets, we just multiply each number here, each term here by every term over there, all right? And add all the stuff together. Combine anything, any that are like terms, all right? So we're going to start by doing 4x times x squared. That's going to give us 4x cubed. I tell you what, I'm not going to do this one just yet. You guys do it. All right, I'm going to give you just a minute to do it, and then I'm going to see if we all got the same answer. Okay, I'm going to do it on my piece of paper right here. Who thinks they've got it? What you got, Kobe?
4x to the third plus 2x squared plus 14x minus 8.
That's what I got too. Did anybody else? Did anybody not get that? You didn't get that? All right, so let's walk through it. That was the correct answer. Let's see how we got it. 4x times x squared is 4x cubed. 4x times x is a positive 4x squared. 4x times 4 is a positive 16x. Now we're going to do the negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times x is negative 2x. And then negative 2 times 4 is negative 8. All right, any questions about how I got those values? Does that make sense?
I got it right. I just haven't simplified it.
Oh, you haven't
That's
simplified
why.
it yet. Okay, so but you got all those correct? Excellent. All right. So the only things that we can combine together on this one now, and this is the way these will usually work out. Like the first term and the last term, there usually won't be anything to combine those with, but then the stuff that's in the middle will often combine with something else. So here we've got a 4x squared and a negative 2x squared that we can combine together to be positive 2x squared, right? Because 4 minus 2 is 2. And then we have a 16x and a negative 2x, and 16 minus 2 is 14, so we have a plus 14x, and then finally minus 8. So that would be our final answer. All right? Any questions about any of this? Multiplying polynomials. questions? All right, cool. Thanks for taking it easy on me, guys. Let's see. So I want you guys to understand, and some of you I'm sure already have this down, but I also know sometimes I'll show this to students and it's just like the light bulb comes on like, oh, okay, I get that. So if you have a, and this is going to be important when you start using graphing calculators and you're entering stuff in your graphing calculator. If you have an equation like this, y equals 2x plus 4. And we're thinking about the graph of this function, okay? This particular equation here happens to be the graph of a line, all right? If we had an equation like this, y equals x squared minus 2 plus 4, that's the graph of a parabola. So this graph here is just going to be a line that looks like that, and this one here is going to be something that looks like a parabola, looks like a U, right? So anytime you have just two variables in there like this, it's going to be something that you can graph on a coordinate plane, right? What do we mean by a coordinate plane? Sometimes you'll hear it called a Cartesian coordinate plane. What do I mean by that? Okay.
It's like a bunch of lines put into like the squares.
Yeah, but and what's the key? There are two key lines on there that represent what? The x and the y-axis, right? So it's the thing that looks like this, where this is the x-axis, and this is our y-axis. And like Cohen said, maybe I'll draw that with a different color so we can distinguish the x and the y. Like, we usually have lines across here, right? Our graph paper looks like this, and then we've also got lines that go down here. I have a little graph thing that I can stick to the board, and I forgot to bring that today. So that's what we call our coordinate plane, or our Cartesian coordinate plane. And so I could actually graph these things on this right here. And the way that I can do that is by picking x values and then see what y value I get when I plug those in. All right? So let's just say, for example, this one right here. If I pick an x value and plug that x value in this equation, then whatever I get is going to be my y value. And that should be sort of obvious the way that it's set up, right? If I plug let's just kind of pick some easy numbers. If I plug in a -1 here, what am I going to get for what y is equal to? If I plug in a -1 for x, there's going to be 2 times -1, which is what? -2 plus a 4, which is 2, right? So it's just going to be, when x is -1, then y equals +2. All right? Let's pick another really easy value. Let's pick 0 for x. If x is 0, what's y going to be? Nope, if I plug in 0 for x, that's 0 times 2, which is 0. But then when we add 4 to that, we get 4 on this side, so y is going to be equal to 4. Does that make sense to everybody what I'm doing? I'm doing y equals, for the first one I did y equals 2 times -1 plus 4. And I said that equals -2 plus 4, which equals 2, which is what we got for y. And then for the second one, I said x equals 0, so 2 times 0 plus 4 equals 0 plus 4, which equals 4, right? So I can plug in a value for x, and I'll get a value for y, right? We'll do one more. I'll plug in 1 here, which all should be really easy math. So y equals 2 times 1 plus 4, so we've got 2 plus 4, which equals 6. So y is going to equal 6. Does everybody see that? So when you have an equation like this, there are an infinite number of x values that I can put in there, and there will be an infinite number of associated y values that will result from that when you have an equation, all right? But when I'm drawing a line, I actually only need 2 points. So I could graph this guy here by saying, if x is -1 and y equals 2, so here on my x-axis, if I start out from the origin in the middle here, Then I go -1 places on the x-axis. So I start here, and I go -1, and then I go +2 places on the y-axis. So I've got a point right here. And then for the next point, I go 0 places on the x-axis. So I stay right here, and then I go +4 places on the y-axis. So I go 1, 2, 3, 4. Right here, right? And then that would allow me to graph that line that I just calculated points for, all right? I could do the same thing with the parabola. I could pick easy values for x and figure out what y would be, all right? So I want to make sure that you guys get this, and I want to make sure that everybody's comfortable graphing points on a coordinate plane. You guys definitely should have done that before, but I just want to kind of test you on that. What is this point? What is this first point right here? So how do we do our points? We do it like this, with a comma in between it. What goes right here? -1, right? And then what goes right here? Huh? 2, right? So the 2 goes right there. So that point is -1, 2. We went, right, this is our positive direction on the x-axis. This is our negative direction on the x-axis. This is our negative direction on the y-axis. This is our positive direction on the y-axis. So we went one place in the negative direction on the x-axis, and then we went in the positive direction 2 places along the y-axis and got to that point, right? And then the same thing with the next one, right? This point here is the point 0, 4, because we went 0 places on the x-axis and we went 4 places in the positive direction on the y-axis. So I don't want to spend too much time on this because I feel like you guys have probably done this lots of times before, but I do. Is anybody still like not super comfortable working, and are you comfortable telling me that in front of the class? Right? It's good to kind of iron this out now if you struggle with graphing on a Cartesian plane. You guys are still struggling with that? All right, so let's talk. It's kind of, I think one of the things that helps you with this is playing Battleship growing up. So if you played Battleship and you kind of went along the grid there, that's very similar to the way this works, right? So let's just let's go through another example. And it's very much like what we've done on the number line, right? So we had our number line, and we went in the positive direction here, and we went in the negative direction here. So that's exactly what we're doing on our Cartesian plane. This would represent our x-axis. It's just for our y-axis, we have a number line that runs like this, right? Where this is 0, and then this is 1, this is 2, this is 3, this is -1, this is -2, and this is -3, right? So that's the way our y-axis is laid out. And so if I have a coordinate, so let's say I'm told to graph +2, -3. All right, that's the number that I want you to graph, and that's actually, I think that's kind of what the homework problem is for this. It's just giving you. This is what we call an ordered pair. So this is an ordered pair. And the first value represents the value on the x-axis, and the second value represents the value on the y-axis. And so we're asked to graph this ordered pair on a rectangular, that's another name for it, a rectangular coordinate system or a Cartesian coordinate system or a Cartesian coordinate plane. Those are all names for the same thing. So we always start here at this center location, right, where the x and the y-axis cross. That's our starting point. And so remember, this represents our direction, how far we're going in the x direction. This represents how far we're going in the y direction. All right? So I'm going in my x direction. I start there and I do x first. And this tells me I'm going 2 places in the x direction. Right? So I'm going to start at the beginning here and I'm going to go 1, and then I'm going to jump over 1 more. 2 places in the x direction. Right? In the positive x direction, right? Just like on a number line. This is the positive direction, this is the negative direction. So this is a +2, so I'm going to go 2 places in the positive direction. This number here says along the y-axis, in the y direction, I'm going in the negative direction 3 places, all right? So now I'm going to hop from here 1, 2, 3 places down in the negative y direction, right? And I'm going to end up at this point right there. All right? Does that make sense to you guys? You see how I got to that point? So let's try one more. Let's try going -3. Let's see if we can do -3, 4. So I'm going to erase some of this stuff here so it won't be distracting to us. All right. So we're going to go -3, 4. So I'm starting off with my x-axis. Which direction am I going, Cooper? Going this way, right? So I'm coming over here 3 places, right? So I'm going 1, 2, 3 places over that way. And then which direction am I going on my y-axis, Madeline? Huh? So this is my x one, this is my y one. Is this one positive or negative? No. So right here, so I'm going -3. Which direction am I going on my y-axis? Up, right? Because that's the positive direction here. So I'm going to jump from this point 1, 2, 3, 4. So that right there would be my -3, 4. Does that make sense to everybody? You guys got that? Cool. So there's some problems for you to practice that. Like I said, this is just one of the areas that I see sometimes students have holes in their understanding. So we want to make sure we plug those holes now, and you guys get this, so that you'll have it going forward. All right. So you'll have an opportunity to practice that. And like I said, eventually where we're going with this is we'll have an equation. And as long as we're good at plotting these coordinate pairs, we can just plug in numbers for x and we'll get associated y's. And so to graph the line, we're going to plot -1, 2. We're going to plot the ordered pair 0, 4, and we can even plot the ordered pair 1, 6 if we want to. All right? So that's where we're kind of heading with it. All right, any questions about that? That's good? All right, let's see. Well, this is actually the next section. So we're doing it right now. All right. So let's do one. Let's do this again. I'll keep my little graph up here, and let's do some other equations. We're not working with parabolas yet. We're not going to get quite that complicated, but let's work with some other linear equations, which just means it's an equation for a line. Okay. So let's do y equals -1/2 x plus 2. Okay? Now again, my recommendation when you're doing this is to pick values that are going to make the math easy. All right? So pick values for x that are going to make the math easy. So what would be a nice easy value to plug in for x here? Where I can just in my head look at it and go, oh, that's the value for y. What do you guys recommend? And I'll just say, since this one's got a fraction, I would recommend picking values for x that's going to get rid of the fraction also. 2. 2, right? 2 would be a great choice. So if I plug in 2, 2 times -1/2 is, just again, making sure everybody knows what I'm doing. I'm doing y equals -1/2 times 2, I'm plugging that in for x, plus 2. So what is that going to end up being? 2 times -1/2 is -1, right? And -1 plus 2 is +1, right? So our y value is going to be +1. All right? -2, we picked that because that was what was on the bottom of our fraction here. So that got rid of the fraction. I'm sorry, we picked +2 because it got rid of the 2 on the bottom of our fraction. But do you guys see that negative 2 would do the same thing? So let's choose negative 2 for a value. Negative 2. Negative 2 times 1/2 equals positive 1. And 1 plus 2 gives me positive 3. All right? And then just for grins, we'll do another one that's sort of in between those two. That would be a simple one. 0 is often, right, it's usually a good choice, since that will make the whole x term go away. This is 1 equals negative 1/2 times 0 plus 2. And what's my y value going to be for that?
2.
Just 2, right? 0, 2. All right. So let's take this guy. I'll tell you what. I'll draw another graph here. First of all, I want to make sure that everybody's clear that what we just did was we just found 3 ordered pairs, right? 3 coordinates. And our coordinates are 2, 1, negative 2, 3, and 0, 2. Right? That's what we've got to graph on our coordinate plane. Maybe I can use this. That's what we've got to graph over here in order to get the equation for our y. All right? And so we'll use this one. We'll just use the other marker that I have so that we can distinguish this line that we're graphing from the other one we're graphing. So our first point is 2, positive 1. So we're hopping over 2 places to the right because the x is positive, and then 1 place up for the y because the y is positive. So we're going to have a point right there. Right? That's 2, 1. That's that coordinate. Then we're going to do negative 2, 3. So we're jumping negative 2, or 2 places to the left on the x-axis. And then we have a positive 3, so we're going to go 1, 2, 3 up. So we're right here. That's our negative 2, 3 point. And then finally we got to go 0, 2. So we're not moving anywhere on the x-axis, but we're going up 2 on the y-axis. So we're right here. So those 3, what color is this one? Is it light blue? I was afraid it was purple. My color blindness doesn't help much with blues and purples sometimes. So that would be the equation for that one. Does that make sense? Yes.
So do we decide what x is?
We just pick it. Yeah, we just pick x values that are going to make the math easy here. All right? And that's why we pick these. Make sense? Any x value will work. Just pick the ones that are going to, like I wouldn't have picked 500 for x, right? Because you probably don't want to, 257 or 259, 250, yeah, it'd either be 252 or 248. That's probably not, you don't want to draw a graph like that, right? So yeah, pick numbers that make it really easy and give you really small numbers here too. Yes?
May I also use yours?
Yes, go ahead. All right. The other thing that's kind of that's a little bit weird for these is the graphs of vertical lines and the graphs of horizontal lines. So I just want to make sure that you're able to recognize those. And those will always look like this. You'll have y equals some number and nothing else, right? So you might have y equals, we'll do y equals negative 2. All right. So if you just see y equals some number, then that's going to be a horizontal line. It means that for any value of x, right, you can think about it like this. If I pick any value of x, if I do negative 1, 0, positive 1, 8,394, right? No matter what value of x I pick, what's y always going to be? It's always going to be negative 2, right? So if you think about that, it makes perfect sense what we're doing. This point is negative 1, negative 2, so I go negative 1 down to negative 2, so I have a point right here. And then this one's 0, negative 2, so I come down to negative 2 right here. And then positive 1, negative 2 would be right here. And if I went to 8,394 way out there, I'd still go down negative 2. And so this is going to look like, it's just going to be a line that intersects the y-axis at negative 2. Right, so that's a horizontal line. What do you think vertical lines might look like? Like, what do you think that the equation might be for a vertical line? That's an equation for a horizontal line. Any idea? Pick a different color. that I can see. Oh, wait a minute. I thought that was red. That's not. Is that brown or green? What is that? Is it what?
I think it's red.
Oh, is it red? Okay. Is it? Did I have the wrong top with the marker?
It looks brown here. In the red cap.
Yeah, I don't know. Maybe you're colorblind too, man. Y'all think it's brown?
That's red.
Okay, so that's red as well.
It's a darker red.
A darker red? Okay. I wonder if I wondered if I had my caps mixed up, because that doesn't look like the same color as that. But I guess this isn't quite the same color as that either, is it? So, any ideas what a vertical line would look like? A line that goes straight up and down? If the graph of a horizontal line, if the equation of a horizontal line looks like this, then it should make sense that the graph of a vertical line looks like this. And so we'll say x equals 3. Okay? And so what that means is that no matter what value of y we pick, x will always be 3. Right? So we're always going to be over here where we go out to x equals 3, right? And it's gonna just go through all of these points. And that would be the graph of a line that was x equals 3. Right? So horizontal lines are just y equals some number, vertical lines are x equals some number. Okay? Does that make sense to everybody? Got that? Joni, you missed that, so I'm just going to reiterate it since you're walking in. If you see y equals a number, that's a horizontal line that passes through -2. So we drew this line here. If you see x equals a number, that's a vertical line that passes through the x-axis where x equals 3. Okay, so that's how we recognize those. All right, let's go. Where are we? How we got a few more minutes. Actually, closer to 20. So let's go on to lesson 52, and we'll stop there. And this is a pretty easy concept. We know how to take the average of numbers, right? If I told you, if I said the test scores were 90, 88, 95, and 82, right? Those were your test scores. And you wanted to calculate your average. How would you do that?
You add them all up and then divide them by the numbers.
By the total number, right? We add all those together. We'd say 90 plus 88 plus 95 plus 82 divided by 4. Right? So that's simple. It's straightforward enough. What if we wanted to get the overall average, and we were told this, that let's say we're talking about so let's say we had 7 numbers, and we had 6 of them. Well, we'll continue to use this. All right, let's say you've got this number of grades here, and maybe that was your test score your first semester, okay? And then maybe the second semester, you had a test score of, maybe you did much better, right? So 92 and 94. You dipped down into 80 one time, but it's barely an 80, and then a 96, and then you nearly aced this one here. All right, we got 5 grades for that one. So to find the average for this, we would do 92 plus 94 plus 89 plus 96 plus 99. And we would divide that by what? 5. We've got 5 numbers this time, right? So can someone tell me what those values would be?
The first one was 88.75.
88 point what?
75.
88.75. Okay. And then what about the second?
$94.
94? All right. So we got 94 right here. So let's just say that was our first semester test and this was our second semester test, okay? Well, our overall test average in the class, you might think I could just say, well, 88.75 plus 94, take that and divide it by 2. What does that end up being? Did you get it?
Not really.
88.75, okay. Alexa's like, this is a lot of pressure. Just on me.
135.75.
Yeah, you did the same thing I did. You did put parentheses around the first two. Right, we got to put parentheses around the first two, because I'm sure you get a value that's between those two numbers. So that's actually 91.375. All right. That is not an accurate representation of my overall average. Does anybody know why? Yes.
Because there's 3.
Because there's
Oh wait, no.
Anybody have any idea?
Did you round up?
No. The reason that's not an accurate representation of my overall average is because I had 4 test scores up here, but I had 5 down here. It's kind of like the idea when you take a weighted average, right? Like one number counts more than the other. This number counts more than this one because I had 5 test grades that were averaged into that number, all right? And so if I had these two averages here, and I wanted to know what the overall average actually was, then in order to calculate that, I'd have to say, let's say I didn't know the individual test scores, but I knew there were 4 of them, all right? And I didn't know the individual test scores here, but I knew there were 5 of them. I could get the overall average by doing this. I could do 4 times 88.75, right? I had 4 test scores, multiply that times the 88.75, plus 5 times what my average was for my 5 test scores, which was 94. And then I take that and I divide that by the total number of test scores, which was 9. Okay, so if I do this, that will give me a true overall average. And so let's see what that turns out to be. 4 times 88.75. I think my batteries are getting close to dying here. Yes. Divide that by 9. So that actually turns out to be 91.67 if I round. So my overall average then for this was a 92, whereas my overall average for this was a 91. Right? So we want to do the overall average, because that's going to give us the most accurate, the more accurate score. All right? Did you guys see how you would do that? So so for example, they might give you a problem in the book that says that the average of the first 90 minutes was 4, and the average of the average of the first 90 numbers was 4. So average of 90 numbers was 4, and the next 10 numbers, the average was 6. So average of 10 numbers was 6. And then they ask us for the overall average. So the overall average, based on the way that I explained this, how would you do the overall average? Who thinks they could walk me through that? I have 90 numbers that had an average of 4, and I had 10 numbers that had an average of 6.
Would you multiply them?
So I multiply the 90 and the 4, plus the 10 and the 6. Since I've got 10 numbers that had an average of 6, right? Just like we had 5 numbers here that had an average of 94, I took the 5 and multiplied it by the 94. I'm multiplying the 10 times the 6, I'm multiplying the 90 times the 4, and what am I dividing by? Yes? 100, right? Because that's the number of numbers. We had 90 numbers plus 10 numbers, which is a total of 100. So that's the math that I've got to do to figure out the answer to that. When I plug that in my calculator, I get 4.2. Make sense? Any questions about that? You have a question or you're just resting? It's a very tiny question. All right. Nothing else about that? All right. One more thing I want to show you and we'll be done for today. Now that we know how to multiply polynomials, we can do a problem like this. Like I'm about to sneeze. Let's say we have this problem: 4x plus a over, I said a, not a 9, 4x plus a over a plus b. And we want to add that to c plus x. All right? You're like, are you kidding me? That looks crazy. But we just have to remember what we do whenever we, and actually, you know what? We may have already done something similar to this. This kind of seems familiar. But we should be more comfortable with this now that we're doing more complicated multiplication problems with polynomials. If I have a fraction like this and another fraction that's like this, how do I add those together? What was my first step?
Change the denominator.
I need to get a common denominator between the two, all right? So what would my common denominator be?
6.
6. How'd you get that? Where'd you come up with 6?
So multiply the bottom two.
You multiplied 2 and 3 together, right? Because you know for a common denominator, you got to get the smallest number that both of those things will go into, right? And in this case, they'll both go into 6, right? So what I've got to do in order to give them a common denominator is I've got to multiply the top and bottom of both of these by whatever number is necessary to make it a 6, right? So I've got to multiply. Why am I multiplying the top and the bottom?
Because whatever you do to the top, you do to the bottom.
Whatever I do to the top, I get into the bottom. I'm effectively multiplying the whole thing by 1 because 3 over 3 is 1, right? So that's why I'm allowed to do that. So I'm going to multiply top and bottom by 3 here because that's what's going to make this a 6, right? So I'm multiplying everything on this side by the thing that's the denominator on this side, right? And then for the other one, I'm going to multiply everything by what? Top and bottom by 2, right? Because again, I want to get 6 on the bottom. So I'm multiplying everything here by what's the denominator on this side. So when I do that, I get 9 over 6 plus 8 over 6, right? And when I add it together, I'm doing the 9 plus the 8. You add the numerators together, and what goes on the bottom? 6. You don't add the denominators, right? You just put whatever our common denominator is down there. This is exactly the same process that we're going to do here. All right? In order to add these together, I've got to get a common denominator. And so what I'm going to do, I know that my common denominator is going to be x times a plus b. Does everybody see that? Just like we saw our common denominator here was 2 times 3. Here my common denominator is take what's in the denominator of both of these and multiply them together. All right? And so that means that for my first term, I'm going to have to multiply top and bottom by what? This is the denominator I'm shooting for. x, right? Because that's what's missing in my denominator, the x part. So I have to multiply top and bottom by x, right? And then for this one over here, what am I going to have to multiply top and bottom by? A plus b, right? Does that make sense to everybody? You see why I'm having to do that? Let me ask it this way. Does anybody not see why I'm having to do that? Have I lost anybody? I'm just doing the same steps we did over here when we had numbers, right? So now I can say then all of that is, this whole thing is going to be over x times a plus b. And on the top, I'm going to take this x times 4x plus a and add that to the c times a plus b, right? Because what do we do when we add them together? We don't add the denominators, we only add the numerators, right? Is that as far as I can go? We actually know how to multiply through, right? So we could multiply through and just see, and that's a good idea, so we can see if anything will, if we've got any terms that we can combine together. So if we multiply through, I'm going to multiply an x times a 4x plus a, so what's that going to give me? Somebody tell me what x times 4x plus a would be. I'm multiplying every term by x.
4x squared plus ax.
Yep. Does everybody see that? He multiplied the x times each term. X times 4x is 4x squared. X times a is ax. Right? So we're going to have all of that plus c times each of these terms. So c times a is going to be ac. I'm going to write them in alphabetical order. And c times b, positive b, is going to be plus bc. All right? And then all of that still is, you could multiply through on this if you want to. In the book, they just leave it like that because it's not going to simplify any further. And then after we've done that, we just take a look at this and say, are there any terms that will combine? Do we have any terms that have the same exact variables that are like terms? We don't, right? So we actually can't simplify this any further. None of those combine, so we're done. Does that make sense to everybody? Any questions about this or about anything that we did today? What's your rule? If you do a problem and you're like, I don't understand this, and you look at the solution, you figure out how to do it, then you do it right. Either do that again, or probably what would be even better was pick another problem that's a similar problem and see if you can do the other problem and get it right. So do more problems. The more problems you do, the better you're going to get at it. All right, you guys have a good day.